Hi guys, this is just a quick recap video just to remind you how to do lesson 3-6. If you're watching this after winter break, it'll be a good refresher. I kind of figure some of you guys, if you've taken a breather for a little bit, it's going to be helpful to have something to rewatch to remind you how to do the worksheet. So get out your 3-6 practice worksheet. We're going to go through just a couple problems on there just as a refresher. Pause me if you need to. I'm going to switch slides. So the first one I want to go through is the geometry problem. So it says that the table shows the number of diagonals. Diagonals means, so if you have some sort of polygon, maybe you have a hexagon, a pentagon, a triangle, whatever it may be. Diagonals are where you go across. So, that's a diagonal, that's a diagonal, that's a diagonal. You could also do from here. This is how some people make art. There's a lot of geometry art that we could explore if we had the time. Sadly, we do not, but there's a lot of geometry in art. Super cool. Anyways, so when you're talking about the vertexes, that's the point of your polygon. So a lot of times, you'll see it in triangles. The diagonal is where you cut across. Some people prefer their sandwiches sliced this way. That is diagonally. There's hamburger hot dog style folding. Those are not diagonals. Diagonals are from corner to corner. And the vertexes are the points. These are vertex. I thought it was helpful, not in the sense of you absolutely need to know this for the problem, but it's nice to know what they're talking about. So let me get rid of this. Just wanted to give you some context for that. So it wants us to write the equation in function notation for the relation. So there's a lot of information that we don't necessarily need, but that they give us just in the context of, why is this important? This is a story problem. So we want to look at sides and diagonals. Seems like the diagonals depend on the side, so I'm going to call the diagonals y. Y is the dependent variable, and we'll call the sides x. I want to know what my change in y is each time. It looks like to get from 0 to 1, 1 to 2, 2 to 3, we are adding 1 each time. Then if I were to compare the sides from 3 to 4, 4 to 5, 5 to 6, that's easy too. We are increasing. So every time you add a side, you add a diagonal. Where this comes into play, and this is not necessarily that important for this lesson, but that's all right. So if we have a square, there are exactly 2 diagonals. If you add a side, if I can draw it, okay, and you have 1, 2, you start to add the diagonals. Anyways, so it seems like it increases by 1 each time for this geometric polygon. And then we want to check out, what is the intercept? Because we need the slope and the intercept. Let's get a fun color here. So I want to know what my m is. First, I could do that. Remember, m is the change in y. That's what that delta symbol means, over the change in x. I named diagonals y, and that was 1. That's how much we changed each time. And then the sides are x, and that was 1. So your slope simply is 1. Then we want our b, or our y-intercept. That's when x is 0. We don't actually have that here yet, so we need to figure that out. If I were to backtrack, it would be 2, 1, 0. Just going to write right over the top. Then we would go -1, -2, and -3. It seems like this is a little bit weird because if we want to write an equation, we can't really have negative diagonals. There are no diagonals once you get to something with 2 sides. Why is that? Because you can't make a shape with 2 lines. If there are 3, a triangle, there's no diagonals. If there's a square, you could draw 1 if you're going from just one spot. So in this case, find the number of diagonals that can be drawn from one vertex in a 12-sided polygon. So if you have a 12-sided polygon, as you increase in sides, how much do you increase in diagonals? Well, you could look at this from sides. You have to start with 3 sides. So you could also think about your intercept as 3. Because of the relation, you could have also flipped it if you wanted to. So when we're looking at this, you could put it as y equals your slope, your ratio is 1x plus 3, because whatever it is you're starting with, you add 3 to it. Because you don't have diagonals in a triangle. If you try to draw a diagonal from here, it just goes here or it goes here. The first one, if you pick one vertex to draw it from, is right here. Then as you go, if you're picking just one vertex. So these are the diagonals, but if you pick just one vertex, it would be just one across there. We're getting muddled up in it though, so I'm gonna kind of speed things up here. So if I want a 12-sided polygon, if I have 12 sides, that's times 1, but then you have to add 3 to it. So 1 times 12 plus 3. 1 times 12 is 12. And 12 plus 3 is 15. So you would get 15 diagonals. And that's how you would answer this problem. That's as far as I'm going to go with that. Pause me if you need to write this down. I'm going to switch slides. The other type of problem you want in function notation is when you get a linear graph. So again, you want to know what your slope is and you want to know what your intercept is. Just looking at this graph, where our y crosses is at 0. So our intercept is 0. The second thing I want to know is what kind of slope I have. So we're going to draw what's called a slope triangle. And in this case, it is negative because it's going downhill. So you have -1, -1. Then we go over 2, so our slope is -1 over 2. It's an easy way to remember which one goes on bottom. Then instead of y, we're going to say f of x equals our template of mx plus b. And then we'll just plug in the values we figured out. So we'll have f of x equals, our m was -1 over 2, or -1/2, x plus 0. If you have plus 0, you can leave it just like it was before, or you could add the plus 0. It is up to you. And that's how you do those problems. The last type of problems, if you need to pause this, write it down, go ahead and do that, by the way. Last type of problems is proportional or non-proportional. So that's where you are going to, figure out, is it increasing by the same amount each time? So for number 6, you go +2, +2. For 7, it looks like +5, +5. So it is proportional each time, and then we'll explain, every time you add a number, you add 3. Or 2, I guess, in the case of 6. Go ahead and finish that up. Hopefully that's a good refresher for you. Appreciate you taking the time to watch this and getting your work done. See you guys.